Okay, more solving for theta. This time they're going to be a little different, a little easier in some ways than yesterday. Okay, so here's what I am asking you to do in this problem. I'm asking you to figure out sine in this case. I want you to think about this. If you had an algebraic equation like this, how would you solve it? And there's actually a couple different ways you could do it. One of the ways would be to divide by 4, and of course x squared is 1/4, and then take the square root of it, okay? The other way you could do it, if I gave you something like this, would be to get everything to one side, and then realize that it was a perfect square, and factor it like this, and go from there. Okay, and either way will work here too. I don't think most of you will realize that perfect square part, so I think most of you will divide by 4. So I'm going to do it that way. And then I have this, sine squared is 1/4. And then just like if there was an x there, you're going to get sine by itself. So you are going to need to square root both sides. And just remember, when you square root both sides, the one thing you need in front of there is a plus or minus, and it's the one thing that people get wrong a lot. Don't forget to put positive or negative in there. So the square root of 1 is 1, and the square root of 4 is 2. So the square root of 1/4 is 1/2. So now you have to figure out where on your unit circle is your sine value either positive or negative 1/2, and you have to find both spots. Okay, so I'm going to look at my unit circle. I need every spot because notice there was no -1 symbol or no arc in that beginning problem, and so I'm not looking for restricted intervals. I need every spot. So I need all the spots where sine is positive or negative 1/2, and I can see from the graph that there will actually be 4 of them. There's my positive 1/2s, and here's my negative 1/2s. You probably won't be looking at the graph. You probably will do your unit circle. So your sine values are positive 1/2 here at pi over 6 and at 5 pi over 6. And they're negative 1/2 down here at 7 pi over 6 and 11 pi over 6. So my answers to here are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay. I do not need to do anything else here, because this is just plain old theta. So I don't need to do the whole 2 pi k thing, which is great news. Okay, so these are actually my 4 answers, and I am done. All right, you are going to think of these things as the signs, the trig functions, as like x's. Okay, so if I asked you to solve an equation like this and where there was these signs, you had x's, I'm guessing you would figure out that what you want to do is move everything to one side. So I'm going to move that to the left and that to the left, and of course make them positive. And then when you have something like this, you need to factor. Okay, so if I factor this, the two fronts, of course, have to make 2 sine squared. So this will be 2 sine and 1 sine. 2 times sine, 1 times sine makes 2 sine squared. And then, of course, the back two have to make 1. So 1, and both positive. Of course, if it's positive at the end, they could either be both positive or both negative, but because my middle term is positive, this will be positive. Then you need to set each parentheses equal to 0, just like if you were factoring this. 2 sine theta plus 1 equals 0, and then sine theta plus 1 equals 0. Okay, and of course solve. So here I will subtract 1 and divide by 2, and sine will be negative 1/2. And over here I will subtract 1, and sine will be negative 1. So I first of all need to look over here for where sine is negative 1/2. Where's your y value? Negative 1/2. So I go over here, and my y values are negative 1/2 at 7 pi over 6 and at 11 pi over 6. Okay, so there's my answers there. And then on the right, I'm needing to figure out where sine is negative 1. And the only spot where my sine value is negative 1 is at 3 pi over 2. And again, just remember, I'm giving you, you need to give me every spot on the unit circle, not just the ones in the restricted intervals, because there's no negative 1 or arc symbol. So I need those 3 answers for that problem. Okay, this one is very similar, except for notice I have sines and cosines in the same problem. And if you want to be able to factor it and all that good stuff, you can't have sines and cosines. So you want to probably replace this with its identity. And the identity for cosine squared is 1 minus sine squared. So now I have all sines in my equation. And I am going to distribute that 2 through. Okay, I will combine my like terms over here. And then of course I want to get everything to one side. And I liked my sine squared term to be positive, so I'm going to move that and that. All right, so it should look like that. And of course now if you look back at the last problem, it is the exact same problem as this one. So I'm not going to go through it anymore, but I started with 2 sine squared plus 3 sine plus 1, which is of course where I am at right here. So I am just going to say right now, same as number 2. Okay? All right, this one, same kind of thing, a little different, but you have cosines and sines in the same equation. Notice this says cosine 2 theta, and you have some formulas on your master formula sheet that will be useful to you, namely the double angle formulas. And the double angle formulas for cosine, if you look at your formula sheet, there are 3 of them. And so you need to think about which formula you're going to use for the cosine 2 theta. Notice you have sine. Your choices, if you look at your formula sheet, are cosine squared minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1. Notice you have a sine right here. And you can't have different trig functions in the same equation and be able to solve them. So you want to pick the one that only has sines in it, since I already have sine in my equation. So I am going to replace that cosine 2 theta with 1 minus 2 sine squared. And go from there. All right, I am going to add 3. And I'm going to just kind of switch the order on here. So I have negative 2 sine squared plus 2 sine plus 4. Okay. And then I'm going to notice that I can factor a negative 2 out of here. If I factor a negative 2 out of here, then I have sine squared minus sine minus 2. Okay, so then I am going to undo the FOIL here on this middle part. Sine squared, of course, is sine times sine. 2 is 1 times 2. It's negative, so I need 1 positive and 1 negative. I need the 2 to be negative and the 1 to be positive. Then I'm going to set each part equal to 0. So I will have negative 2 equals 0. And then I will have sine theta plus 1 equals 0. And I will have sine theta minus 2 equals 0. Okay, well, negative 2 never equals 0, so we don't need to worry about that. Here I will get sine equals negative 1, which is a spot on my unit circle. Here I will get sine equals 2. Okay, so first of all, I'm going to look on my unit circle for where sine is negative 1. And if we do that, sine is negative 1 down here at 3 pi over 2. Okay, the next part is asking me to figure out where is sine 2. And sine is 2, if you look at your unit circle, sine never gets to 2. Okay, the highest sine gets is 1, the lowest it gets is negative 1. It never gets to 2. So there's not going to be a spot on your unit circle. Some of you may not remember that off the bat, or you may not realize that, and so then you'll go to your calculators. And if you go to your calculator, and your calculator's in degree mode, and you put in inverse sine or second sine of 2, you will get an error when you do that. There is no spot on your unit circle where sine reaches 2. Not when I have a normal sine graph where I haven't changed the period or the amplitude or anything. It won't reach 2. So 3 pi over 2 is the only spot. All right. Then a couple more here. Again, you can see that you have sine and cosecant in the same equation. And that can't happen. So I am going to replace cosecant with 1 over sine. I'm going to multiply both sides by sine. That will drop. 5 times sine times sine will be 5 sine squared. Okay, divide by 5. So I have sine squared equals 4/5. And then of course I need to take the square root of that. And again, when you take the square root, don't forget to do plus or minus. Okay, when you take the square root of a fraction, it's like taking the square root of the numerator over the square root of the denominator. Obviously, the square root of 4 is 2. The square root of 5 is root 5. Can't leave a radical in the denominator. So you will have 2 root 5 over 5, plus or minus. Okay? So, you need to figure out where sine is either positive or negative 2 root 5 over 5. And this is a little bit tricky for you to think about, but we can do this. Notice there's no place on your unit circle that you have coordinates for where sine is positive or negative 2 root 5 over 5. Okay? It's not going to happen. So what you need to do in this case is you need to use your calculators. Okay? And so we are going to boot these up for a minute here. You're going to use your calculators. I want to make sure that your calculator is in degree mode because it's easiest to think about this in degrees. It's coming here, so hang tight. All right. So I want to first of all make sure my calculator is in degree mode, which mine is not. Okay. So I'm first of all going to put in second sine of 2 root 5 over 5. Okay, and one answer is 63.43 degrees. So one answer is 63.43 degrees. I'm going to go over here and I'm going to show you this here. So 63.43 degrees is right about here. Okay, so there's one answer right there. 63.43 degrees is the first answer to our problem. Okay, now what I want you to think about though is this. The sine value at this spot, of course, is this distance right here. Okay, and then I want you to think about, is there another spot on the unit circle that has that same up, down, or sine distance as that does? And of course there is, and it would be right over here that has the same sine value. Okay, so the other answer that you need is this answer right over here. And I know that this angle is also 63.43 degrees. But my question is, because we have to measure angles from 0, so I need to know what is this distance right here? What is this angle? Because I have to measure it from 0. So this angle will be 180 minus 63.43 degrees. Okay, so then you need to figure out what's 180 minus 63.43, which of course you can figure out. And that will be 116.57 degrees. So I need that answer as well. Okay, then you need to go back to your calculators and you need to put in inverse sine. So I need to go second sine again. And this time I need to do negative 2 root 5 over 5. And this time I get negative 63.43 degrees. I will never let you have negative answers as your answer, so I always want you to have your answers in positive form. So negative 63.343 degrees is right down here. This angle is 63.43 degrees. Okay, but I don't want that. I want you to measure the distance from 0. So you can see that this 63.43 degrees makes you 63.43 degrees shy of one trip around the unit circle, or shy of 360 degrees. So to figure out this spot down here, I will go 360 minus 63.43 and figure that out and get 296.57. So that's one answer. And of course, you need its partner, which would be down here. So this is the other spot that has the same y value as that one. This angle is 63.43, but you need to measure that spot from 0. So this 63.43 degrees right here puts you at 63.43 degrees past 180. So to figure out that spot, I'll go 180 plus 63.43. And I don't know why I'm using a calculator, because I can do this in my head, but I don't want to mess up for you. 243.43. So you need all 4 of those answers for this problem right here. All right, and our last one right here. Many of you are going to be tempted to solve this by doing this. Dividing by cosine, dividing by cosine. They cancel, and you get 2 sine, and you're good, you think. Okay, here's the deal. Only do that as an absolute last resort. What I want you to do first is to try to subtract things all to one side and factor. If you can subtract and factor, you have to do that as your first option, which I can here. 2 sine theta cosine theta minus cosine equals 0. Okay, now I'm going to factor a cosine out of here. And when I factor a cosine out, then I'm going to have 2 sine minus 1 equals 0. So here I have to look for, where is cosine 0? Where's my x value 0? Here, if I set this equal to 0, I'm going to end up looking for, where is my sine 1/2? Okay? So if you look at your unit circle, your cosine values are 0 at pi over 2 and at 3 pi over 2. So pi over 2 and 3 pi over 2. And your sine values are 1/2 at pi over 6 and at 5 pi over 6. And there you go. All right, and I think we are going to skip this one for right now and go from there. Okay, I lied. Sorry, we're not going to skip. So, first of all, I want you to replace this cosine squared with its identity, which is 1 minus sine squared. Okay. Then combine your or move this 2 over, let's say. Okay, then I'm just going to switch the signs on these and get them in the right order so that they're factorable. So I'm going to switch the signs and make this be positive sine squared, negative sine, positive 1. Okay, so now I'm going to try to factor this, and this is what happens. You have sine and sine, 1 and 1, and I can either do plus plus here or I can do minus minus here, but either way it doesn't factor. So when things don't factor, then you get to do the quadratic formula. I know, it's so fun. Okay, so if you don't know the quadratic formula, here it is. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and remember your a comes from the number in front of your squared term, your b comes from the number in front of your regular term, and your c comes from your constant here. So in this case, my a is 1, my b is negative 1, my c is 1. Okay, so I'm going to do this. Sine at theta is this number, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Or sine at theta equals 1 plus or minus. Inside that radical, I have 1 minus 4, which is negative 3. And because I get a negative underneath here, you're not going to have imaginary solutions on the unit circle. That's not going to work. So because I have a negative underneath here, then your answer will be no solution. I don't want you to think, though, that just because something doesn't factor and you have to go to the quadratic formula, that it's automatically no solution. We're going to see in future days that there are other things you can do and there will be solutions. In this case, because I got a negative underneath the radical, there is no solution. Okay, now we're done.